Hello, my dear children. In this chapter, Relations and Functions, in the exercise 2.1, we have learnt Cartesian product of two sets. Okay, my dear children. And the points related to the Cartesian product of two sets. Now, in the exercise 2.2, we are going to discuss the following 4 points. Are you ready to get the knowledge on these 4 points, my dear children? Are you ready to study these 4 points well, my dear children? Right. See, the concepts or points. The first point is relation. We discuss the definition of a relation. What is meant by a relation? And its representation. How can we represent a relation? That is the first point. And second point, domain of the relation. What is the domain of a relation? That is the second point. And third point, range of a relation. How to find the range of a relation? What is the definition of range of a relation? And the fourth point is total number of relations. Total number of relations. Okay, my dear children, are you ready to get the knowledge on these 4 points? Right. Now come to the first point, that is relation and its representation. We are defining here relation. We are we are discussing the definition of a relation. Okay, my dear children. So here a relation or, generally we denote a relation by capital letter R. Throughout this exercise, remember this point, my dear children. Here R denotes a relation, not a set of real numbers. Okay, my dear children. A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. Relation is a subset of the Cartesian product of two non-empty sets A cross B. The subset. Now a question arises. How do you define a subset? How do you get a subset of A cross B? The subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. You know, in A cross B, there are some ordered pairs. In the ordered pairs, again you know here, ordered pair means there are two elements, two objects, first object, comma, second object. In a bracket, in a small brackets, we write first element, comma, second element, or first object, comma, second object. So here we describe a relationship between the first element and the second element. So we have to we have to choose the ordered pairs which satisfy the given relationship between the first element and second element of the ordered pairs in A cross B. The second element is called image of the first element. In the ordered pairs, the first element is there and the second element is also there. In the case of relations, the second element in the ordered pair is said to be the image of the first element. Okay, my dear children, let us take an example to understand this definition clearly. Okay, my dear children, right. Let us take an example to understand the definition of a relation. See here, let A is equal to set 1, 2 and B is equal to set 3, 4. Okay, my dear children. Then A cross B. You know how to find the Cartesian product of these two sets. You have already learnt in exercise 2.1. Recall that previous knowledge here. So I wrote here set A cross set B. 1, 3, ordered pair 1, 3, ordered pair 1, 4. Understood these two ordered pairs, my dear children? Right. Now we take the second element of the first set and we connect with every element of the second set. So 2, 3, ordered pair 2, 3, ordered pair 2, 4. So these are the ordered pairs in A cross B. Okay, my children, understood this one? Now let us define a relation R1. Let us define a relation R1 such that set of all ordered pairs x comma y, set of all ordered pairs x comma y such that x plus y is an even number. Here we defined a relation between the first element and the second element of the ordered pairs. What is the relationship between first and second elements of the ordered pairs? X plus y. The sum of the two numbers in the ordered pairs should be an even number. So here in these ordered pairs we have to check which ordered pairs satisfy this relationship. See here 1 plus 3. This is first number and this is second number. Imagine this is x and this is y. 1 plus 3. What will you get here? 4. 4 is an even number or not? Yes. So we can write this ordered pair in R1. Okay, my children. Comma 1 plus 4. What will you get here? 5. Is 5 an even number? No, it is an odd number. Therefore, we should not consider this ordered pair in R1. We should not write it here. Understood this point, my dear children? Now come to the third ordered pair. 2 plus 3. 2 plus 3. What will you get here? 5. Is it an even number? No, it is not an even number. It is an odd number. So this ordered pair is also should not be written in the R1 because this ordered pair is not satisfying this relationship. Understood the point, my dear children? Right. Next we take this ordered pair. Ordered pair 2, 4. 2 plus 4. What will you get? 6. Is it an even number or not? Yes. It is an even number. So we have to consider. We should consider this ordered pair in R1. Ordered pair 2, 4. I wrote ordered pair 2, 4 in R1. So these two ordered pairs, only these two ordered pairs in this A cross B satisfy this relationship. Understood this R1, my dear children? Similarly, here, what is the image? 3 is called image of 1. Previously, we discussed that point also, image of an element. The second element is said to be the image of the first element. So here, this is the first element, this is the second element. So this 3 is the image of 1. Similarly, from this ordered pair, here 4 is the image of 2. Understood these two lines, my dear children? Right. Now let us define another relation R2. We are taking another example. From this A cross B only, we are defining another relation. R2 is equal to set of all ordered pairs x comma y such that x is a factor of y. This is a relation defined. This is the relationship between x and y is defined. Understood this relation, my dear children? Right. So in this A cross B, we have to identify the ordered pairs which satisfy this relationship. So in this R2, take this first ordered pair. This is x and this is y. Imagine in your mind, this is x and this is y. 1 is a factor of 3 or not? Yes. So we can write this ordered pair in R2. That is an element in the R2. Next, to take this second ordered pair. 1 is a factor of 4. True or false? Yes. 1 is a factor of 4. So you can consider is an element of R2. Now come to the third ordered pair. 2 is a factor of 3. Is it a true statement? No, it is not a true statement. It is a false statement. That is why this ordered pair is not satisfying this relationship. That is why we should not write this ordered pair as an element in this R2. Understood this point, my dear children? Right. Any confusion, my dear children? Right. Now come to the fourth ordered pair. 2 is a factor of 4. Is it a true statement or not? Yes, it is a true statement. 2 is a factor of 4. So we can write this ordered pair as an element in relation R2. So only these three ordered pairs are satisfying the given relationship between x and y in the Cartesian product A cross B. Understood this point, my dear children? Right. Here 3 is image of 1. 4 is image of 1. Similarly 4 is image of 2. So for the elements 1 and 2, for both elements 1 and 2, 4 is image. Understood this point, my dear children? Right. In the first chapter, sets, you have learnt that there are two methods of representing a set. What are the two methods? Roster method, and the second one is set builder form. Set builder method. Roster form and set builder form. Here also the relation can be represented in these two methods. See these examples R1. Here this R1 is represented in the set builder form. This representation of their relation is called set builder form. Whereas here the relation R1 is represented in the roster form, because we have written all the ordered pairs. We listed out all the ordered pairs which are satisfying the given relationship between x and y. So this is a roster form. Come to the second relation R2. This method is called roster form. Set builder form. This is called set builder form. And this second one is called roster form. Understood, my dear children? So we can represent a relation also by the method of roster form and by the method of set builder form. Understood, my dear children? Right. Now come to the next point, that is representation. Here we wrote R1 in the roster form. Here also we wrote R2 in the roster form. Here we are giving a diagrammatical or pictorial or visual representation by the method of arrow diagrams. With the help of arrow diagrams, we can give a visual representation of a relation. See here, I have drawn an arrow diagram. Set A, in that circle set A, I wrote the elements of the set A 1 and 2, and second set, in the second circle I took the set B. Elements of set B is 3, 4. See here, one is associated, one is related to 3. So I have drawn an arrow from 1 to 3. See the second ordered pair, 2 is related with 4. So R2 is associated with 4. So I have drawn an arrow from 2 to 4. Understood this visual representation of a relation, my dear children, by the method of by the means of arrow diagram. Come to the second relation R2. This is a roster form of this R2. Now we are giving visual representation of R2. See arrow diagram. By the means of arrow diagram, we are giving a visual representation. The same set A, elements 1 and 2. Here set B, 3 and 4. See, 1 is related to 3. So, from 1 to 3, I have drawn an arrow. Understood this point, my dear children? Right. Similarly, see the second ordered pair. 1 is related to 4. 1 is associated with 4. So from 1 to 4 I have drawn an arrow. Understood this point, my dear children? Right. Third ordered pair, 2 is related to 4. 2 is associated to 4. So I have drawn an arrow from 2 to 4. For these 1 and 2, these two elements, 4 is a image. Understood, my dear children? Right. So here the first point is over. I hope you have understood the first point well, my dear children. Okay, my dear children, now come to the second point. Let us discuss the second point. What is the second point? Domain of a relation. We define here the domain of a relation. How to find the domain of a relation? We take some examples to understand the definition of domain of a relation. Okay, my dear children, see the definition. The set of all first elements of the ordered pairs in a relation R from a set A to set B is called the domain of the relation R. So in a relation, you know, there are some ordered pairs. So from that ordered pairs, we have to select, we have to focus, we have to concentrate on the first elements of all ordered pairs in the given relation. Okay, my dear children, understood this definition? Let us take an example to understand this definition clearly. Let us take this R1. We have already written R1. In the first point, we have discussed this point. R1 is equal to set ordered pair 1, 3, ordered pair 2, 4. We have written this R1 for the first point. We are using the same example here also, R1, relation R1. Then the domain of R1. How to find the domain of R1? What is the first element here in this domain, in the ordered pair? 1. So 1. From this ordered pair, in this ordered pair, what is the first element? 2. So set 1, 2 is called the domain of R1. Understood this point, my dear children? Right. Let us take the second relation R2. We have already discussed in the first point. The same relation is taken here. R2 is equal to set ordered pair 1, 3, ordered pair 1, 4, ordered pair 2, 4. Then what is the domain of R2? What is the domain of R2? The first elements. What are the first elements here? From this, in this ordered pair, what is the first element? 1. What is the first element in this ordered pair? 1. You should not write, we should not repeat any element in a set. All the elements of a set should be distinct. Okay, my dear children, they should be different from other elements. So I am not repeating the element 1. And what is the first element in this ordered pair? 2. So here the domain of R2 is set 1, 2. Understood this point, my dear children? Right. The second point is over. I hope you have understood the second point well, my dear children. Okay, right. Now come to the next point, third point, that is range of a relation. Here we define range of a relation. Okay, the set of all second elements of the ordered pairs in a relation R from a set A to a set B is called the range of the relation R. Understood this definition, my dear children? The range of a relation R means the set of all second elements of the ordered pairs in the relation R. The set of all first elements of the relation R is said to be domain. The second point we have discussed. Now the range of the relation R is the set of all second elements of the ordered pairs in the relation R. And the whole set B is called the codomain of the relation R. The whole set, second set B is called codomain. And note that range is a subset or equal to codomain. Sometimes range is a subset of codomain, or sometimes range may be equal to codomain. Means they may be equal sets. Understood this point, my dear children? Let us take an example to understand this point, my dear children. Let R1, the previous example, R1 is equal to set ordered pair 1 comma 3 comma ordered pair 2 comma 4. Then what is the range of this R1? What is the second element of this ordered pair? 3. What is the second element of this ordered pair? 4. So 3 comma 4. Set 3 comma 4 is the range of the relation R1. Understood this point, my dear children? Right. Let us take the second relation R2. R2 is equal to set ordered pair 1 comma 3, ordered pair 1 comma 4, ordered pair 2 comma 4. Then in the first ordered pair, what is the second element? 3. In the second ordered pair, what is the second element? 4. In the third ordered pair, what is the second element? 4. Again, no need to write here 4. Understood this point, my dear children? Therefore, range of R2 is equal to set 3 comma 4. Understood this point, my dear children? Right. Now let us take another example to understand all these points well. Okay, my dear children? Right. See this example. Let A is equal to set 1, 2, 3, 4, 5, 6. These 6 are the elements of set A. Define a relation R from set A to set A by R is equal to set of all ordered pairs x comma y such that y is equal to x plus 1. This is a relationship between the first and second element of the ordered pairs. Okay, my dear children? So, see the question. Depict this relation using an arrow diagram. And second part, write down the domain, codomain and range of R. Understood this question, my dear children? Right. So, here it is very difficult to write A cross A because 6 elements are there. So, without writing A cross A, by using this relationship between x and y, we write the ordered pairs. Y means the second element, x means the first element. So, if you take first element 1, second element should be x plus 1. So, 1 plus 1, 2. If you take first x is equal to 2, what will be the second element? 2 plus 1, 3. Understood this ordered pair, my dear children? If you take 3, x is equal to 3, then what will be the second element? 3 plus 1, 4. Understood this ordered pair, my dear children? Right. If you take x is equal to 4, then what will be the second element? X plus 1, that is 4 plus 1, that is 5. Understood this ordered pair, my dear children? Right. If x is equal to 5, if x is equal to 5, then y is equal to 5 plus 1, that is 6. So, ordered pair 5 comma 6. Understood this ordered pair, my dear children? Suppose if x is equal to 6, what will be the y value? 6 plus 1, 7. But 7 is not there in the set A. That is why we are not considering that ordered pair 6 comma 7. Understood this point, my dear children? Right. So, these are the ordered pairs in the relation R. Only these ordered pairs satisfy the given relation between the first and second element of the ordered pairs. Understood this point, my dear children? Right. Now, we represent this relation by an arrow diagram. This is the visual representation of the relation R. So, set A, first set is A and second set is also A. From A to A, R is defined. So, A is equal to 1, 2, 3, 4, 5, 6. In the second set also I wrote elements 1, 2, 3, 4, 5, 6. Here 1 is related to 2. 1 is related to 2. So I have drawn an arrow from 1 to 2. So here image of 1 is 2. Image of 2 is 3. Image of 3 is 4. Image of 4 is 5. Image of 5 is 6. 2 is related to 3. So I have drawn an arrow from 2 to 3. 3 comma 4. So 3 is related to 4. So I have drawn an arrow from 3 to 4. 4, 5. So I have drawn an arrow from 4 to 5. 5, 6. So I have drawn an arrow from 5 to 6. Here 6 is not taken to draw an arrow. Here also 1 is left. Understood this arrow diagram, my dear children? Right. So this is the first part of the question. We have represented the relation or by the method of arrow diagram. This is a visual representation of the relation or. Now come to the second part of the question. We have to find the domain of R, codomain of R, and range of R. What is the definition of domain of R? The set of all first elements of the ordered pairs in relation R. So what are the first elements of the ordered pairs in the relation R? Here first element is 1. So I wrote here 1. Here first element is 2. I wrote here 2. Here first element is 3. I wrote here 3. Here first element is 4. I wrote here 4. Here first element is 5. So here I wrote 5. This is the domain of R. Understood this point, my dear children? I hope you understood well this point. Okay, my dear children? Right. Now come to the codomain of R. What is the definition of codomain of a relation R? The whole second set. The whole second set is called codomain of the relation R. What is the second set here? A. So set A, all the elements 1, 2, 3, 4, 5, 6, all the elements in the second set is considered as codomain. I hope you understood this point well, my dear children. Okay, right. Now range of R. Recollect, bring back that definition of range of a relation R into your mind, my dear children. What is the definition of range of R? The set of all second elements of the ordered pairs in the relation R. What are the second elements of the ordered pairs in this relation R? 2. I wrote here 2. Here 3 second elements, only second elements. Here second element is 4. Here second element is 5. Here second element is 6. Understood this point, my dear children? Range of a relation R. I hope you understood this point well, my dear children. Right. Now come to the last point, that is the fourth point, total number of relations. How to find the total number of relations defined from a set A to another set B. See this point, the total number of relations that can be defined from a set A to a set B is the number of possible subsets of A cross B. Okay, my dear children, the number of possible subsets of A cross B is nothing but the total number of relations that can be defined from a set A to set B. If n of A is equal to P, this notation denotes number of elements in the set A. Let us consider P. And n of B is equal to Q. Number of elements in the set B is Q. Then you know that n of A cross B is equal to PQ. In the previous exercise, in exercise 2.1, you have learnt the number of ordered pairs in A cross B. N of A cross B is equal to PQ. And the total number of relations is 2 power PQ. The number of subsets, that concept is used here in the first chapter sets. we have learnt the number of subsets of a set 2 power n of a. Here a means pq, 2 power pq. Understood this point, my dear children? Right. Now, to make this point very clear to you, I am taking an example. Okay, my dear children, to understand this point well, I am taking an example. Let a is equal to set a is equal to 1 comma 2 and let b is equal to set 3 comma 4. Find the number of relations from a to b. Okay, my dear children, you have to recollect, bring back that previous knowledge of the number of relations that can be defined from set A to set B. Here n of A, that is equal to P is equal to 2. How many elements are there? 2 elements are there. N of B denotes number of elements in the set B, that is considered as Q. Q is equal to how many elements are there? 2. Therefore, total number of relations from set A to set B is equal to 2 power PQ, that is equal to 2 power, in this formula, P is equal to 2 into Q is equal to 2, 2 into 2. Understood this step, my dear children? Right. That is equal to 2 power 4. What is the value of 2 power 4? 16. Therefore, we can define 16 relations from A to B. I hope you understood this point well. Okay, my dear children? Right.